Okay, so good afternoon, all of you. Welcome to the mathematics class. Today we are going to discuss the assignment 2. Actually, assignment 2 is triangles topic, actually question paper questions. Okay, so that question paper questions we have to discuss now. Yes, students. See, we are discussing actually assignment 2. Okay. Yes, assignment 2. In that first question is state basic proportionality theorem. You all know the definition of basic proportionality theorem, right? If a line drawn parallel to one side of a triangle to intersect the other two sides in distinct point, the other two sides are divided in the same ratio. You all know you have to write this statement. Okay. So then second question state yes criteria for similarity. If in two triangles, sides of one triangle are proportional to the sides of the other triangle, then their corresponding angles are equal and hence the two triangles are similar. You all know the SSS criteria for similarity. Okay. So you have to write the definition for that. Next, third problem, the area of triangle ABC which is equal to 16 centimeters square and area of triangle DEF is equal to 25 centimeters square and BC is given 2.3 centimeter, find EF. So, two triangles area is given and two triangle related one side is given BC and EF. BC is a side of ABC triangle, EF is a side of DEF triangle. When two triangles area and sides given, so you have to recall one important property that the ratio of the areas of two triangles is equal to the ratio of the squares of corresponding sides. Okay, so very important statement, very important problem. Actually, the ratio of the areas, here you can observe ratio area of ABC divided by area of DEF, which is equal to ratio of the squares of the corresponding sides. Got the idea of this one now? Ratio of the squares of the corresponding sides. Then here area of ABC is 16, area of DEF is 25, which is equal to BC side is 2.3, EF side is EF only, that is only question mark no whole square. So now what we have to apply, we have to transfer this power 2 to this side, then it becomes square root of 16 by 25. You all know 16 and 25 are the perfect square number now. So then you will get 4 by 5. After removing the square root sign, then you will get 4 by 5 which is equal to 2.3 divided by EF. Now cross multiplication. 4 EF which is equal to 2.3 into 5. 4 into EF which is equal to 2.3 into 5. 2.3 into 5, here the result is 11.5. Then EF which is equal to 2.875, that is 11.5 divided by 4. The answer is 2.875. So the EF answer is 2.875. See students, this is also 1 mark question only. Fadafat you have to calculate this one in the examination, because for 1 mark question and all you cannot take much time, no. So in 1 minute only you have to finish 1 mark question. Got the idea of this question, students? Yes. So now the fourth question is like this. State the converse of the following statement. State the converse of the following statement. Actually, one statement is given. So for that you have to give the statement of the converse for that. Okay. If a line drawn parallel to one side of a triangle divides the other two sides proportionally. A line drawn parallel to one side of a triangle. Okay, one line so drawn parallel to one side of the triangle, okay, which divides the other two sides proportionally. Now you have to give the converse of this statement. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. You all know how to write the converse statements, no, right now? See here, actually parallel condition is given in the statement only beginning. One line parallel to the another side of the triangle, then the two sides will be in the same ratio. Okay, so then reverse converse is, if a line, not a parallel line, in the beginning you cannot say that it's a parallel line. If line which divides the two sides of a triangle in the same ratio, then the line must be parallel to the third side. Got the idea of this one now? Actually, this is the statement of which one? BPT, right? Okay, yes. Now let us move on to the next question. Okay, yes. Next page, fifth question. Okay, so 1 second, students. For that, can I get the full screen? Stop video. If we of the video full for the recording, no. So we have to fix the camera. Okay. See here, fifth one. In the triangle ABC, angle B is 90 degree and BD perpendicular to AC. In the triangle ABC, angle B is 90 degree. BD perpendicular to AC. This BD is perpendicular to AC. If AB is 8 centimeter, AB is equal to 8 centimeter, AD is given 4 centimeter, find the length of CD. This CD length we have to find out actually, okay. So what is given? ABC, B 90 degree. This is a right angle triangle is given. Then one more data is given that BD perpendicular to AC. This BD is perpendicular to AC. Here also you will get 90 degree. Okay na? So then AB 8 centimeter. This measurement is 8 centimeter. Then AD this much only 4 centimeter. Find the length of CD we have to find. This CD measurement we have to find. So you all are observing that this is 90 degree in the sense, can I get this right angle triangle actually? In the triangle ADP. So if we applied Pythagoras theorem, it is possible to find out DB side. Okay. Now, in the triangle ADB, so Pythagoras theorem, the square on the hypotenuse which is equal to sum of the squares of the other two sides. Then BD square plus AD square which is equal to AB square. Then BD square plus AD is 4 square is equal to AB square. Then BD square plus 16 which is equal to AB measurement is 8. 8 square is 64. Then BD square is equal to 64 minus 16, that is 48. Then BD which is equal to 48 you can split as 16 into 3. So then 16 comes outside 4 root 3. BD measurement is 4 root 3. Now, so CDB triangle and ADB triangle are similar. How can we say that similar this one? I need the explanation from your side. So can we say that triangle CDB and triangle BDA, this triangle and this triangle, so is it similar triangle? CDB and BDA, can we say the similarity? How can we say the similarity? Yeah, similarity. So here she gave the answer actually. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Yes, we discussed this property while discussing triangles topic, right? No? So what is that? If a perpendicular is drawn from the vertex of a right angle of a right triangle. See, ಈ perpendicular ಯಾವ್ದ್ರಿಂದ ಬಂದಿದೆ? Vertex, right angle in right triangle in a right angle ಇಂದಾನೆ ಬಂದಿದೆ. ಹೌದಾ ಈ perpendicular? ಸೊ ಇದು ಆಕ್ಚುಲಿ ಪೈಥಾಗೋರಸ್ ಥಿಯರಮ್ ನ ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ ನೀವು. ಈ ತರ ಡ್ರಾ ಮಾಡಿದಾಗ ಏನಾಗಿದೆ, ಹೈಪೋಟೆನಸ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಬಂದಿದೆ. ಈಗ BD, AC is hypotenuse of ABC triangle. No, then the triangle on the both side, ಈ ಟ್ರಯಾಂಗಲ್ ಮತ್ತೆ ಈ ಟ್ರಯಾಂಗಲ್ ಆಕ್ಚುಲಿ ಒರಿಜಿನಲ್ ಟ್ರಯಾಂಗಲ್ ABC ಗೂ ಸಿಮಿಲರ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ಒಂದಕ್ಕೊಂದು ಕೂಡ ಸಿಮಿಲರ್ ಇರುತ್ತೆ. ಸೊ ಈ ಪ್ರಾಪರ್ಟಿಯನ್ನ ನಾವು ಟ್ರಯಾಂಗಲ್ ಪಾಠ ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಹಾಗಾಗಿ ಟ್ರಯಾಂಗಲ್ CDB is similar to triangle ADB. Okay, two triangles are similar, then their ratio are in proportion. No, then CD divided by BD, CD divided by BD which is equal to BD divided by AD, BD divided by AD. So CD divided by BD, therefore we got the result that CD divided by this triangle BD, which is equal to BD divided by AD. Okay, CD, this side, ratio of CD by BD of CBD triangle, which is equal to BD by AD of this ABD triangle. Then CD only. BD we got 4 root 3. Here BD 4 root 3 divided by AD measurement is given 4. Okay, now, so here 4 get cancelled. Then root 3 divided by 1 will be remaining. CD by 4 root 3 is equal to root 3 by 1. Then CD cross multiplication. CD into 1 is CD only. Root 3 into 4 root 3. Then root 3 into root 3 is 3 only. 4. Actually 4 into 3 is 12. CD value is 12 centimeter. Got the idea of this one, students? See here. CD divided by BD, which is equal to BD divided by AD. So this ratio we can take for the CD measurement. Now CD length we got 12 centimeter. Got the idea of this question, now, students? Yes. So next, sixth one. Again, it's a definition part. State the converse of Pythagoras theorem. State the converse of Pythagoras theorem. In a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right triangle. Okay, so actually in a triangle, converse, here the word is converse. Actually, converse beta. If state the Pythagoras theorem, then in any right angle triangle, we have to start the definition with in any right angle triangle, the square on the hypotenuse, which is equal to sum of the squares of the other two sides. Okay, but now it is converse of Pythagoras theorem. That's why in a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right triangle. Okay, then the triangle is right triangle. That type also you can write the definition of the converse of Pythagoras theorem. Okay, yes, now total 6 questions over. Seventh one. In a triangle ABC, in a triangles ABC. So one more thing I want to tell, actually, whatever the theorem related questions are there, no, theorem, state and prove Thales theorem, state and prove Pythagoras theorem, that theorems and all. So you all know theorems, no? And again, I'm not going to explain that theorems part. Okay, only we are discussing the problems. Is that clear? So that theorem and all, you have to complete that theorem work. So very important. So all the theorems you have to learn properly. Okay, so now seventh question is like this. In a triangle ABC, XY parallel to BC, okay, apply basic proportionality theorem. You all know basic proportionality theorem in the sense that is only Thales theorem, no, to this triangle. So in mathematical form, okay. So in triangle ABC, XY parallel to BC. Here XY parallel to BC. Okay, apply basic proportionality theorem to this triangle in the mathematical form. That is nothing but again Thales theorem proof only. Okay, so now ABC triangle, here we have to take XY line is parallel to BC line. You all know Thales theorem, no? So we have to join this BY and XC, then here XM and YN. Like this you have to draw the diagram. Given, what is given actually in a triangle ABC, XY parallel to BC is given. To prove, what we have to prove here actually, AX divided by XB, which is equal to AY divided by CY. Okay, AY divided by CY. These two sides, okay, so corresponding to these two sides, equal ratio, same ratio. AX divided by BX divided by AY divided by CY we have to prove. We have to apply Thales theorem only. Okay. So now construction. Draw XM perpendicular to. You all know the Thales theorem construction. XM perpendicular to AC we have to draw. YN perpendicular to AB we have to draw. Then join X to C. Then join B to Y. Okay, so you all know the general. Okay, same to same Thales theorem only. Next statement. One side you have to write the reason. Area of triangle AXY, okay, divided by area of triangle BXY. Which two triangles we have to take here? This AXY, then BXY. So you all know the area of triangle formula, half into base into height. So we have to apply that half into base into height formula. Okay. So here in the triangle AXY, half into base is actually AX, height is NY. Height is NY. Next, divided by in a triangle BXY, base is BX. Okay, half into base is BX. For this triangle also height is NY only. Okay, height is NY only, 90-degree line. Then this half cancel, NY cancel, remaining is AX by BX. And same to same concept we have to apply for one more ratio, that is in area of triangle AXY. Now again same to same triangle we have to take in the beginning. Now second triangle, this one we have to take, this side, CXY. Area of triangle AXY and area of triangle CXY. In the beginning step actually, area of AXY, then this one. Area of BYX we have to take. Now area of AXY and this side, area of CXY. Same to same concept we have to apply, half into base into height, half into base into height. There half cancel, height, the XM cancel, okay. Then AY by CY. Okay, so then AY, see here, AX by BX which is equal to AY by CY. Why? Because area of BXY which is equal to area of CXY. I'll explain this one in the help of a diagram. Area of AXY, so BXY, area of this BXY which is equal to area of CXY. Are you all observing the diagram here? See here, area of AXY, area of CXY. 9th standard topic you have to remind. What is that? So, if two triangles standing on the same base between the same parallels, then their areas are equal. According to that condition, this BXY and CXY both are standing on the same base XY between the same parallels, then their areas are equal. So, therefore, what we can take actually, this AX by BX which is equal to AY by CY. So this is all equal, no? BXY, CXY equal. Here AXY same to same we are taking. So that's why AX by BX which is equal to AY by CY, according to axiom 1, things which are equal to the same thing are equal to one another. This is again the Thales theorem, right? No? Yes. What next? 8th problem. Okay, 8th problem is like this. 1 second, students. Camera can fix me. Okay, students. Now, 8th problem explanation. Okay, so the page is visible, no? Okay. See, 8th question is like this actually. In the figure, O is a point inside the triangle PQR. I'll show the picture in the next page. Okay. First, let us understand the problem. Okay. What is there in the problem? In the figure, O is a point inside the triangle PQR such that angle POR is equal to 90 degree. Angle POR is equal to 90 degree. OP is 6 centimeter. OR is 8 centimeter. Angle QPR is 90 degree. Find the length of QR if PQ is 24 centimeter. This is data actually. Let us see the diagram once. Okay. See the diagram once. PQR is a triangle actually. O is inside the triangle PQR. Okay, such that here OP length is 6, next to OR length is 8, then angle PQ is 24, here angle POR is 90 degree, whether it is given in the problem, let us read the problem again, correct. POR is 90 degree, see here, POR is 90 degree, it is given in the question only. Okay, let us come back to diagram part. Okay, see here, this is actually diagram. POR is 90 degree. Here all these measurements are given in the problems only. Just draw the diagram properly. Next, in a triangle POR, right angle triangle, no? OP 6, OR 8, angle POR 90 degree in the sense you can easily find out PR using Pythagoras theorem. So you all know how to apply Pythagoras theorem. So this is the hypotenuse now. So you all know PR square is equal to OP square plus OR square, Pythagoras theorem. Then calculation 36 plus 64, 100. PR square is 100, in the sense PR measurement is 10 centimeter. We got the measurement of PR 10 centimeter. Okay. So then in a right angled triangle PQR, now we have to discuss in a right angle triangle PQR, here angle P is 90 degree actually. Here angle P 90 degree. Are you all observing the marking? Okay. Then again apply Pythagoras theorem. PQ square. So, okay, PQ square plus PR square, which is equal to QR square. QR is a hypotenuse, no, because the side opposite to 90 degrees is called hypotenuse, no. Okay, 90 degrees here, in the sense QR is hypotenuse. Apply the Pythagoras theorem. Then 24 square plus 10 square. So here PR value, just now we got PR as 10 centimeter. So this problem is completely based on Pythagoras theorem. That's it. Okay. So here QR square, then 24 square is 576 plus 10 square is 100, which is equal to QR square. Then 576 plus 100, which is equal to 676, which is equal to QR square. Then QR is 26 centimeter, because square root of 676, which is equal to 26. Got the idea of this problem now, students? Just using right angle triangle Pythagoras theorem concept, we have to solve this problem. Is that clear? Okay, now let us move on to the next question. So we are not getting any difficult questions, no? All the questions are easy only, no, triangles. Okay, in the figure, angle ABC equal to angle ACD equal to angle ADE equal to 90 degree. If AB equal to BC equal to CD equal to D equal to 1 centimeter. Find the length of AE. So are you all observing? This is actually 9th standard square root spiral, like square root spiral. Okay. See here, in the figure actually ABC, ACD, ADE, all the three angles are equal. ABC, then ACD, then ADE. All these three angles are 90 degree. One more data is given that AB measurement and BC measurement and this CD measurement and DE measurements are equal. One units you can take, no? Okay, find the length of AE. Just remind the square root spiral, you just imagine. Okay, 1 unit, 90 degree. You can calculate this one, no? AC first. Then AC plus 1 unit. You can calculate this one, no? This plus 1 unit. You will get AE. This is like 9th standard problem. So here we are using Pythagoras theorem concept. Okay. See, in a right triangle, first we have to use this first triangle only. Directly we cannot work out for AE. First we have to start with the AC side. Okay. In a right triangle ABC, angle B is 90 degree. Now apply Pythagoras theorem. AB square plus BC square is equal to AC square. So here we are taking this one 1 centimeter, it is given actually. 1 plus 1 is equal to AC square. Therefore, AC is equal to root 2. You all know root 2 construction, no? Now, this is root 2. Actually, here we got root 2. DC, which is equal to 1 centimeter only. Root 2 plus 1. Here you will get AD. Now you have to choose the second triangle ACD. In triangle ACD, angle C is equal to 90 degree. Okay. So now again Pythagoras theorem. So AC square plus DC square is equal to AD square. Got the idea? This is hypotenuse for this triangle. AC square plus CD square is equal to AD square. AC square is root 2 square plus CD square is 1 square, which is equal to AD square. Root 2 square root get cancelled 2. 1 square, 1 only. 2 plus 1 is 3. AD square is equal to 3 in the sense, here AD which is equal to root 3. Illen sigate nimge root 3. Idu root 2, next root 3 sigtade. Now root 3 plus 1 centimeter. Root 3 square plus 1. Can you guess the measurement of this one? Without seeing the answer? Yes, who is ready to give the answer for this AE measurement? We all know. Who is ready to give the answer for that AE measurement? Aniket? Yes, Aniket?